Okay, hello everyone. With a new video of mine about physics vectors, we'll be discussing about the 3D part. In our lessons, we so far have learned the area, the 2D surface, about two lines, calculating with two lines most of the time. Whenever we see the vector products and the dot products, we have worked with the two lines and it was creating a 2D surface. So now there is only one topic that came with you, that you guys have come across, that was you have to determine whether three lines or three vectors are in the same plane, or whether they are coplanar or not. So I'll be discussing about that, what it really does mean. So let's get started. Okay, so first let me recapitulate the things that you already know, that is the area of a triangle. Area of a triangle, that was triangle. I might have some spelling mistakes, please do forgive me for that. So area of a triangle was to be half of the cross products of any of the two sides of the triangle. And when you need to measure the parallelogram, whenever you, I don't know the actual spelling, whenever you have to calculate the area of a parallelogram or samantarik, then you had to use the two sides, any of the two sides. No, they have to be creating an angle. The sides will be creating an angle, like you might take A and B, or you might take, well, let's see a parallelogram here. If it's A, it's B, it's C, and it's D. You can take any two vectors that are creating an angle. So you can take these two, 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 but you never can take the parallel lines together. Like you can't take B and D, you can't take A and C. Why? Look at this. When you are working with a parallelogram, you know the vector signs. These two parallelograms. In this parallelogram, we will trying to measure the area, and here you were, if you do this half A cross C, what you are doing, you are just taking the two vectors A and C, which are both parallel to each other and they have the same magnitude, and you know that half of it will come like half sine theta. And what was the meaning of this theta? The angle between A and C. Try to measure the angle between A and C. It will come whether 180 degree or 0 degree. If I haven't mentioned the direction yet, these are not the actual directions of it. So if you try to measure the directions, it will come 180 or 0. And what if you put 180 and 0 in this theta? The area will come 0. So you never can take two parallel lines to measure area of the parallelogram. So this was it. It was very simple. And when you had two diagonals of a parallelogram, when you were given the diagonals, when you were given the diagonals of it, the area was, oh wait, there was no half of A cross B. There was only A cross B. And when you will be measuring the area with the two diagonals, you will use half of A cross B. And it's not appropriate to write the sides with A and B and the diagonals also with A and B. Let's take a M and N. So what is this M and N? The M and N are respectively the major and the minor axis. You can take the minor first and then the major diagonal. So this was it. If you take the diagonals of a parallelogram and try to measure the area, you will have to cross product it and then multiply with a half, and if you are taking the two sides of a parallelogram, then you will be crossing the two sides of it which are not parallel, creating an angle. So this was it, and let's see what it actually means. The triangle was easier one, you saw it before, long ago, before I'm saying this. So there's no meaning of taking the video too long. Let's see, when you were having a parallelogram, you were given two lines, whether they might be two diagonals or the two sides of it. So let's see, these are the two lines. So whenever you are given two lines, you think, try to understand that why we are only measuring the area, not anything else, not the volume. What was the problem with the volume? So whenever we will be given two lines, okay, let's see these two lines, and what I said, they can't be parallel. If they are parallel, they can be considered as the equal vectors, and equal vectors, cross vectors are equals vectors. If you take the two equal vectors and then cross product it, then put it in the cross operation, then you will get a zero, because they have the angle between them 180 or 0. So you can't multiply, so you can't take the two parallel vectors. So if these two lines are not parallel, then they have to create an angle. So suppose this is the angle, and I am taking these two as the intersecting two vectors or intersecting two lines. Okay, let's see. And when you intersect the two lines, and then you think that, okay, if this is if this is creating, and let's try to keep it on the surface of the board, and then if you take it, we see that it's creating a surface on the board, and you might think, okay, let's tilt this one a little bit. Okay, if you tilt this one a little bit like this way, it also will create an 2D surface. Never two lines will create an. Okay, now if you want to tilt this one, you still can put it on the board. You can try with the two lines. I have taken two sticks, very thin sticks. You can take two sticks or toothpicks or whatever you want. You can also take two pens of yours and try to put it on the on your copy and notebook, or what do I say, and then you will always get a 2D surface. And so we can come to the conclusion that the two lines can only create a 2D surface, or whenever you say you get a 2D, you have a 2D surface, you can only create two lines from it. Oh, sorry, two lines, many of the lines, but you can you can define it with two lines. Yes. Now maybe this is a 2D surface. You can define it with different lines. Like if you take these two, you can say that this is the surface of it. You can take these two lines. It is also saying that these two lines are in this surface. So I'm only taking the surface of the board, and a surface never has a height. So if it doesn't have a height, how can you get the volume of it? The 2D surface will always have a area. It will never have a volume. So you might be thinking, if I am taking two lines, I get a 2D object, then the simple intuition, what it says, that if you take three lines, what you will get a 3D object. Okay, let's see. Let's take another line. Okay, let me put this marker here and say these are the two lines. You can keep it on the board. It's creating a 2D object, and now you are taking another stick and trying to fit it in the frame. And if you take it with this line, with a coplanar, look, this is a coplanar. I'm taking it as a coplanar. So these are in the same plane. If you take it in the same plane, what you will get? Now you will also get a 2D surface. But if you tilt it a little bit, if you take it like this, creating an I'm taking it intersecting with each other. So now you trying to keep it on the board, and you'll see that this line is disturbing us. You can't keep it on the board so easily. So let's take it out here. I'm holding it here and trying to keep it here. Okay, so these two lines are now creating a 2D object or 2D surface, and if you want to put this line on it, what you see that this line might be coming out of the board or going inside the board. So if this happens, it certainly says that this surface has now a height, and you see a height always refer to a 3D object. You have a surface or you have an area, now you have a height. What you will say? You have a 3D object. So these 3D objects, if you take it in a coplanar way, you can say these if the volume comes 0, what you will say, if three lines, okay, suppose this one, okay, now if three lines are creating a volume, then you will say that these are not in a plane. Two might be in the same plane and the other one is not, and so that this is why they are creating a 3D object. And if you say that it's not, I'm not getting a volume, what it will mean? If you don't get any volume, then the height was 0. And how you get a 0 height? This line staying here came on the surface. So if when will it happen? When you get three lines on the same surface, you get the volume 0. This was my point. When you get three lines on one surface, you get the volume 0. Or if you don't have the volume 0, let's try to figure out what the volume will be. The volume will be, you know that you need a volume is a scalar quantity. So you might be thinking, oh, how do I get a scalar quantity? Dot gives me a scalar quantity and cross gives me a vector quantity. And now I have suppose A, B and C, three lines are three vectors. So what I was trying to do, measuring the volume, and I need a scalar quantity, so I have to use two operations together and get a single scalar quantity. So what if I take any of the two, and then do it get a cross product from the two, and then after that with the remaining part, suppose I took A and B and cross producted it, and then I dot product to with the A. So it might come this way. See, when you will be taking this, you will get a vector. Now you will get from this a vector quantity, and this vector quantity, this is also vector quantity, and when you are doing the dot operation, you will get a scalar result. Okay, so this is the simple formula. Or you can even take A cross B and then dot it with the C, or even you can take A and C and then dot it with the B. So the simple way is to take any of the two and then take the vector product of it, that is cross product of it, and then make it the dot operation with the remaining part. So the volume will be simply A dot B cross C, and when you do this, you will get a vector quantity. This cross product will give you a vector quantity, and the final dot product will give you a scalar quantity. Okay, so it's now very simple. So it certainly says if you take three, you will be thinking that I know this, if this result comes 0, this will be in the same plane. Okay, that's what I was saying. this is the volume, and when the volume comes 0, the three lines are in the same plane, and you get it like this. Then, and if it doesn't come 0, then simply what it is, it will be let's say that answer came 10. So if that answer is 10, then it will be saying, we can say that the volume of the 3D object was 10. And if it comes 0, then we'll say that the three lines are in the same plane. They might be creating an area, but they will not create a 3D volume. So let's take, I'm giving you homework, I'm not just I know you guys are already very pissed off, so I'm giving you homework that you will measure 2 volumes. This is number 1. You will measure 2 volumes and say and tell me which will be the which of the 3 lines are in the same plane. So this is A, vector A, I cap 2 j cap plus 3 k cap, and then you get, suppose 7 I cap 8 j cap plus 9 k cap, and then you take 4 I cap 5 j cap plus 9 k cap. You will try this math and calculate the volume for me. Volume, what will be? So do please try this math and take a screenshot or whatever you want, or note down, and then tell me the volume from the number 1 question. And for the number 2 question, for number 2 I change it a little bit, I make it 6k. Okay, so the major changes, this was 9k in the first one and this is 6k in the second one. You will tell me the what will be the for which one I will get the coplanar vectors, or just tell me the 2 volumes of it. That will be easy. Okay, this was easy. Okay, I just rub it out. And what I was, at the end of the day, what you get from this video, it was certainly very simple one. You know it very well. I just explained it, the concept of it. And let's take a shortcut from here. When you have the 3 vectors, suppose I was saying A, B and C, and if you want the volume from these 3 lines, you just put it in the determinant. You will put here AX, AY, AZ, then BX, BY and BZ, then CX, CY, CZ. The result will simply be, the determinant will simply be the volume of it. If you get a negative, please omit it, it doesn't make any sense. It will just say that you took the direction opposite. So the result will simply tell you the volume of it. And if you get a 0, they are in the same plane, you can say okay, that was it. Most of you, I think most of you have already seen this thing, but I just tried once for you guys. So this was it. Thank you for staying with me, and please do let me know the 2 answers of the 2 problems. And it was very good having you guys with me. You guys already know me, but I'm trying to get a big squad for me. We'll be doing more things, more exciting things in future. This is a simple one. Okay, have a good day.